Okay, so we're going to continue this video with another few exponential equations, and they're going to keep getting a little more complicated, but we'll still keep using the principle of exponential equality to solve each one. So now in this equation I've done something new. I put all the stuff on the right, and we've just got this little number on the left, and that should distract nobody, right? We're still looking for equal bases on each side. So to do that, move everything that's not this exponential off of the right side onto the other side, and we'll see if that makes an equal base appear for us. So I'm going to do a -3 on both sides. Just get this going. This is going to be -108 equals -4 times 3 to the 4x plus 7. And now I'm going to divide each side by -4. Okay, and I don't have a calculator on me, so just a moment. Let's see, divided by 2, 108 is going to be 54, divided by 2 again. Okay, great. We've got 27. So on the left, we've got 27, and that equals 3 to the 4x plus 7. And as you look at this, you think, remember, we're supposed to get common bases on each side. What can we do with 27? Well, I know 3 squared is 9, and 9 times 3, making this 3 cubed, that's 27. So we can rewrite the left side as 3 cubed. And on the right, you have 3 to the 4x plus 7. Equal bases, so now we drop the base, right? You can cancel out those 3's, and we just get 3, the exponent, equals 4x plus 7, the other exponent. And now this is, let's bring it over here, I have a little more space. Subtract 7 from each side, we get -4 equals 4x, and that means -1 is our answer for x, -1. Okay, let's do another example. In this one, you've got, again, unequal bases on each side, and let's see if we can make some common base between 64 and 16. Now, up until now, we always just apply a square or a cube or a fourth power or whatever to one base on one side, and it turns out to be equal to the other. But look what happens here. If we try 16 squared, I don't know, what is that, like 256 or something? It's not 64, not by a long shot. So all of a sudden, this technique that we've been using is not working, or at least it seems like it's not working. So what can we do? Well, I'm not going to give up on this one. I think there's something going on between 16 and 64. Think about what 16 is. 16 is 2 to the 4th power, right? 2 times 2 is 4, times 2 is 8, times 2 is 16. So let's just put 2 to the 4th power inside the parentheses here, with 4x plus 8 on the outside. And then on the left, what's 64? We did this in a previous problem. 64 is 2 to the 6th power. Okay, so we'll put that in the parentheses, and we have -3x minus 9 as that exponent. Well, now we've got a common base, but those exponents look terrible, so let's try to use some other rules about exponents to work with this. And if you remember, if I have something like a to the n power, and I raise that to the m power, remember what we know from exponentials, this becomes a to the nm. Okay, we just multiply the exponentials together. So really what I'm talking about here is 2 to the power of 4 times 4x plus 8 on the right. And on the left we have 2 to the power of 6 times -3x minus 9 on the left. Well, this is great. We've got common bases, so you can drop the base. And now we get 6 times -3x minus 9 equals 4 times 4x plus 8. And now there's just a little bit of work to do cleaning this up. We get rid of the parentheses, distribute the 6. That becomes -18x minus 54. And on the right, we have 16x plus 32. So keep on working with this until we have all the x's on one side. I'm going to try adding 18x to each side. That gives me 34x on the right. And now let's subtract 32 from each side. So we get, I don't know, like -86 over here equals 34x. And that makes it pretty clear. X equals, if you divide each side by 34, we get -86 over 34. And of course, you could simplify that fraction, right? There's a common denominator or a common factor you can use top and bottom to simplify it, but it's not necessary. The answer is -86 over 34. And I think this is the last equation. Yeah, last one. So as you look at this, all of a sudden there's fractions in here now. There's certainly no way to get a fraction like 1 over 125, raise it to a power, and get 25, right? They don't look anything like. So let's try using something from this last example here, where I first found what 16 equals in terms of a base and 64. 25 should be pretty easy. We recognize that as a common square. So that's just 5 squared. But remember, it's 5 squared raised to the power of negative 9 phi plus 8. Okay. On the right, is there something we can use with 5 to get to 1 over 125? Well, 5 squared is 25. 5 cubed is 125. I have 1 over 125. So what this is on the right side, it's not 5 cubed, because that would be 125. It's 5 to the negative 3. That's going to give me the 1 over fraction that I'm looking for. And I still have that 3 phi on the exponent. So let's simplify those exponents a little bit. I've got 5 times 5 to the power of 2 times negative 9 phi plus 8. And remember, this is using that principle of a to the n to the m equals a to the nm. Right? So on the right, I have 5 to the negative 3 times 3 phi. Equal bases, cross out. So all that's left is 2 times negative 9 phi plus 8 equals negative 3 times 3 phi. And now we just distribute the multipliers through the parentheses, and we get negative 18 phi plus 16 equals negative 9 phi. And we're going to add 18 phi to each side, right? I want to try to balance this equation by adding 18 phi. So I get over here just 16 on the left, and on the right I have 9 phi, which means 16 over 9 is the solution I'm looking for phi.